Think folks will continue to trickle in, but I'm going to go ahead and get started to make sure that we've got time to cover everything. So, um, again, please feel free to introduce yourselves in the chat and welcome to our webinar, Mining at the Grand Canyon. This is a panel discussion on the scope of the toxic threat from the Pinyon Plain mine. And my name is Len Montgomery. I'm the Great Outdoors Campaign Director for Environment Arizona and Environment America. We are going to have a short panel discussion and then a question and answer um, segment. So please use the Q&A function at the bottom of your screen. You can put in questions as the panelists are speaking, and then we'll answer those during the Q&A. So Environment America and Environment Arizona have a mission to protect the natural world, and we work to support local efforts to protect public lands all across the country. We're facing huge challenges in our advocacy efforts right now. Proposals to sell off millions of acres, mass firings of park and public land staff, and plans to roll back national monument protections. We need as much public support as possible. So we're very excited to have you all here. Before we start on today's topic, I want to acknowledge the tragedy on the north rim of the Grand Canyon and the destruction of the historic lodge and dozens of other structures. And as far as I know from the news, there were no fatalities, but a lot of loss. And we're thinking of everyone who lost belongings or for whom the North Rim was a special place and held special memories. And so um, wanted to start out by acknowledging that. And I imagine a number of folks on the webinar probably are thinking about that place today. On a slightly more optimistic note, we celebrated a big victory for public land protection in 2023 when President Biden responded to a tribal coalition proposal and designated the Bav Nuajjo Itak Kukveni ancestral footprints of the Grand Canyon National Monument. And the Grand Canyon Tribal Coalition leads protection efforts in Baj Nuavjo Itak Kukveni in its 13 tribes. Excuse me, it's 13 tribes all maintain strong historical, cultural, and spiritual connections to the Grand Canyon today. When the monument was established, it ended the prospect of hundreds of new uranium mines being opened, which could have been a disaster of epic proportions. But unfortunately, the mining law of 1872 did grandfather in one existing mine, and the Pinyon Plain mine was allowed to reopen. So in this panel, we're going to learn more about the history of the mine, why it's open today, the risks related to groundwater contamination, and the risks associated with hauling the uranium away from the mine and through communities. So I will introduce our three panelists and then turn it over to them. Amber Raimondo is the energy director for the Grand Canyon Trust, where she has had the honor of working with tribes on uranium and land protection issues for the past 9 years. Dr. Laura Crossie is a distinguished professor in the Department of Earth and Planetary Sciences at University of New Mexico. She's actively researched and published on the Grand Canyon and Colorado Plateau hydrology and geology for over 20 years. And she and her husband, Carl Karlstrom, led the team that designed and built the Trail of Time exhibit at the Grand Canyon South Rim for folks that have been there. And Leona Morgan is an indigenous community organizer and activist focused on preventing new uranium mining, nuclear waste dumping, and transport of radioactive materials in the southwestern United States. She co-founded and works with Hall No Radiation Monitoring Project and Nuclear Issues Study Group. Leona is Diné from the Navajo Nation and lives in Albuquerque, New Mexico. And I'm going to turn it over to Amber first to give us some general background and history of the Pinyon Plain mine.
Thanks, Len. Let me just share my screen here. All right. So as Len said, I'm just going to give an overview of the mine, kind of where it is on the landscape, the kind of mining technique that is used to extract the ore, and some background on the general geology in the region. Talk about what's been done to protect this landscape and to try to fight back against this mine, and then why mining is happening now, 37 years after the mine was originally approved in the late 80s, and then get into some of the long-term concerns that the mine causes that my colleagues on the call will elaborate on further. So just to orient yourself, if you're not already familiar, Pinyon Plain Mine used to be called Canyon Mine. It is,
Amber, sorry, you have a box that says continue to share this PowerPoint window in the middle, and I think you need to click continue to share.
okay, I'm not seeing that. Weird. And that's nothing that you can delete. Do you want to, oh, here we go.
There you go.
It was on the other screen.
Oh, no worries. Okay, sorry about that, everyone. Carry
Yeah,
on.
no, thank you. Thank you so much for catching that. And so you can see it here on the map. This is the south rim of Grand Canyon. There's the south rim Grand Canyon Village. Here's Highway 64, the town of Tucson, and here's Red Butte, which you'll hear more about and see from other vantage points. So the mine is about 9 miles as the crow flies from the south rim. And the geology of this region is highly fractured, not just right here, but kind of around the Grand Canyon writ large. And so that makes for some very complex groundwater systems that are really difficult to understand, and that presents a lot of complications for activities like uranium mining. Here is another view of the mine. So here's Red Butte off in the background. And then this bigger water feature you see is the wastewater impoundment. So when we're talking about water being pumped from the mine shaft, which is beneath this head frame here, into the wastewater impoundment, that's what we're talking about. These other containers are extra water storage because the mine is taking on so much water that in the past they've had troubles maintaining freeboard requirements within the impoundment. And then over here you see the waste rock pile. So this is where the overburden from digging the mine shaft goes. And then right next to it is the ore pile, and that's where the actual uranium ore gets stored. So this photo is from before the mine actually started operating and extracting ore. So that's why you don't see anything on the ore pad right there. And then one other vantage point that was taken a little bit closer to present, it's still over a year old, but here's another drone shot that shows after the mine had started operating, you can see some ore getting piled up here. And again, this is the waste rock pile, which has also grown significantly as of this was May of 2024. So the type of mine that happens around the Grand Canyon and the type of mine that Pinyon Plain Mine is an underground mine. So depending on the type of uranium deposit you're working with, the type of mining required differs. You can have open pit mining, you can have in situ leach operations. This is an underground mine. So on the surface, it takes up roughly 20 acres of ground on the surface, and then below ground, this is the breccia pipe here. This is a collapse feature. It's about 2,000 feet deep. It started in the Redwall limestone, and then over time, layer upon layer collapsed on top of that, creating this pipe-like feature that can be roughly 300 feet wide and a couple thousand feet deep. And so the mine shaft is dug alongside the breccia pipe, and then horizontal shafts are dug to access the ore body. Then the rock is hauled up to the surface, put on that ore storage pile before it's trucked to a mill. And in this case, it's the White Mesa Uranium Mill, which is the last conventional uranium mill that is operating in the country. It's owned by the same company that owns Pinyon Plain Mine, and it is over 300 miles from the mine itself to the mill, and it goes through Williams, Flagstaff, and across Navajo Nation, and then past the Ute Mountain Ute community of White Mesa before reaching the White Mesa Mill. Another piece of background I want to just make sure I cover here is kind of what's at stake versus what there even is to be gained, which is not much. So the United States as a whole does not have really great uranium deposits. Globally, um, we have about 1% of global uranium reserves, unmined uranium reserves. Around the Grand Canyon, so the entire region around the Grand Canyon has about 1.3% of that 1%. And then Canyon Mine or Pinyon Plain Mine is even less than that. So just a little bit of background that I think is important, because when we're in this space talking about the risk of this mine, it's important to know like what this risk is being taken on for. And we hear people talking about the need for this mine because of energy security or nuclear security. And even if you're somebody who supports nuclear power, it's really not going to be a significant contributor to any of that. And when we're talking about how much uranium there is to be mined in this region, it's not as easy as saying, looking at a place and saying there's X number of pounds. It depends on several factors. It depends on the quality of the ore, it depends on the price of uranium, and it depends on the cost of the mining method that is being used. And so all of these things combined, um, in order to even access all of the mining uranium deposits that are available in this region, or that we know about in this region, it would have to be your price of uranium would have to be $100 a pound, which it's not, even though it's considered high right now. Right now it's around $78 a pound, and it hasn't reached $100 a pound in many, many, many years, and that was only brief. So that's all to say that Pinyon Plain Mine itself will provide almost nothing relative to U.S. nuclear fuel demand. The mine expects to extract around 2 million, give or take, they keep adjusting the numbers, but 2 million pounds of milled yellowcake in its 5 to 8 year lifetime. In that time, in those same 5 to 8 years, U.S. nuclear reactors will consume 250 to 400 million pounds of yellowcake equivalent. So in terms of what this mine has to contribute to overall um, nuclear fuel supply, it's really nothing. I'll get to this map in a minute, but just to get into some of the history of the mine itself. So Pinyon Plain Mine was first approved by the Forest Service in 1986, and it didn't start commercial operations until 37 years later in December of 2023. Why? Because of uranium prices. But first, we'll get into the uranium price piece more in a minute, but first I want to talk about some of the history that happened between its 1986 approval and today. So from the outset, the Havasupai tribe was strongly opposed to this mine even being approved, citing concerns that they have with the proximity to Red Butte, which is a culturally significant landscape for them. This whole area around where the mine is a place that tribal members have gone for generations to collect medicinal plants, to conduct ceremonies, and to hunt. And so the concerns were strong from the outset, and the federal government moved ahead anyway, in large part because of what Len mentioned. The 1872 mining law has been it's seen as a very permissive law for mining companies, because it basically treats hard rock mining, which uranium is part of, as the highest and best use of the land relative to other uses. So the Havasupai tribe opposed it from the outset. The mine went on standby in the early 1990s before even completing its mine shaft. It had about a 50-foot hole in the ground, and it sat there for years, until 2007. There was a brief spike in the price of uranium as a result of a mine in Canada having some flooding issues and there being some concerns in the market about uranium supply. So when that happened, that caused a brief but very high spike in uranium prices. And between 2007 and 2009, there were over 10,000 mining claims staked in the general region. So Canyon Mine is down here near the South Rim, but this map shows over 8,000 mining claims. There were over 10,000, according to the Northern Arizona Mineral Withdrawal Environmental Impact Statement. So as a result of that, that caused, because of the trauma that the Southwest has seen from uranium writ large, this caused a lot of alarm with tribes, with communities, with local governments, NGOs like mine, and everybody went to bat and tried to get some protections put in place so that all of these dots could not become mines. And in 2012, that was successful with the Obama administration, then Interior Secretary Ken Salazar imposed a temporary 20-year mining ban, which is seen here in these three outlined parcels on this landscape to protect groundwater, citing the lack of good groundwater understanding and good groundwater research to show exactly where groundwater goes and what the risks would be and exactly what needs to be protected. At the same time, just shortly after that, Energy Fuels notified the Forest Service that they intended to resume operations at what was then Canyon Mine. That was allowed by the Forest Service because, again, under the 1872 mining law, requirements for companies to prove valid existing rights they should be stronger, but they can be interpreted less stringently. And so the Forest Service said, okay, you're good to go, you're exempt. That led to lawsuits that were brought by several folks, the Grand Canyon Trust included, the Havasupai Tribe, Sierra Club, Center for Biological Diversity, and others, to try to stop that exemption from taking place. And that those court battles went on from 2014-ish until 2022. Ultimately, we lost again. The 1872 mining law being kind of the crux of that, where the standards for the mine to have to be able to prove that they had an economically viable uranium deposit were pretty low, despite the fact that they had been sitting on standby for 37 years and not operating because prices were not going to yield a good turnout for them. In 2016, the mine shaft is still being dug. They hit significant groundwater. So this is a problem because when groundwater comes into contact with mineralized ore and oxygen, which it previously didn't have access to, but now that the mine is being developed, there's oxygen in the mix. That means that all of these minerals that are in the ore can become dissolved in the groundwater that it's coming into contact with as well. And that is why we'll talk about this a little further on in the presentation, but that is why we're seeing elevated levels of things like uranium and arsenic in the groundwater that's being pumped out of the mine. In 2018, the company finished the development of the vertical mine shaft. And then in 2023, in December, the company began actual commercial operation. And the last thing that I'll mention here was what Len mentioned at the beginning of the presentation, which is that in August of 2023, President Biden designated the Bajno-Wapjo-Itacook-Vini ancestral footprints of the Grand Canyon National Monument, which, among other protections for the region, includes a mining ban for not all of what you see in these boundaries here, but pretty close. And I should have been advancing these, but this is just a look at uranium prices. So when I'm talking about the spike in 2007, that's there. And then it climbed up to $49 by the end of 2022. But in the end of 2023, I believe the prices were close to $90 a pound when they started operating. And here's some photos of some of the organizing that's happened over the years around trying to stop the mine. And here's a picture of President Biden. You can't see Red Butte in this photo, but Red Butte is in the background. And this is a map of Bajno-Wapjo-Itacook-Vini ancestral footprints of the Grand Canyon National Monument in these three parcels here. So I said I would talk about why mining's happening now. It has to do with several factors, uranium prices being the ultimate driver, but uranium prices are going up for several reasons. because electricity demand projections are really high. We're looking at electricity demand projections going up very steeply in the next decade and beyond, in part because of AI data centers and because of things like climate change and requiring more heating and cooling, et cetera. Nuclear is also seen by some in Congress and in the White House as key to meeting that energy demand. And in turn, government policies have started to incentivize nuclear and the nuclear fuel supply chain, including mining and milling. And then when Russia invaded Ukraine in 2021 and continues to do so, a lot of countries like the US have moved away from Russian uranium supplies and started to look elsewhere, and that has caused the price to rise as well. And then things like market hoarding, where companies like Sprott Uranium are hoarding actual inventories of uranium. So here's the 30,000-foot view of concerns that are caused by this mine. There's the concern for groundwater contamination. There's the concern for surface contamination through dust and vegetation. And then there's also a concern for groundwater depletion, because over 70 million gallons of groundwater have been pumped out of this mine shaft to date, and that isn't expected to stop anytime soon. And then there's the concern about ore hauling from the mine over 300 miles to the mill. And I think the last thing that I'll really go into detail here, because I think I'm running out of time, is just that these concerns about groundwater contamination, especially, grow for the trust after closure, because right now the mine has to constantly manage the water flowing into the mine shaft and pump it out and put it into this on-site impoundment and make sure that water isn't accumulating in the bottom of the mine shaft and then traveling elsewhere. But once they're closed, and even if they've filled the hole with that overburden, there's still a concern that groundwater will find its way back in and leach into surrounding aquifers. And the surprise groundwater in a uranium mine is not unfounded. This has happened on the North Rim. The Pine Nut mine was on standby for years, and the companies thought they had sealed the mine shaft appropriately, and they opened it up to restart the mine, and surprise, there were millions of gallons of radioactive water in the bottom of the mine shaft. So this is not unfounded, and in a place where the geology is highly fractured and complex and not well understood, it's really not a risk worth taking. And I've included some slides here just to show you. So this is the previous slide with the bars, and this one showed basically the same thing, but this is just showing you the levels of arsenic, uranium, and lead in that water coming out of the mine shaft. And again, we're not saying that somebody's going to go drink the water straight from the mine shaft. The concern is this water eventually making its way into something that somebody would drink or that would show up in a Zebra Spring inside the Grand Canyon. This is EPA drinking water standards. This is what that water looked like in 2016, and this is what that water looked like in fourth quarter of 2023 after mining had resumed. And then if folks want to have a visual here for what these piles look like, this is the waste rock pile. So for scale, you're standing outside the mine fence. This is what they have to keep dust from blowing off of, and this is the ore pile. So it's pretty sizable that they have to try to keep from blowing off site. Same thing with the wastewater impoundment, that contaminated water blowing off site from the evaporators in high wind conditions. They're not supposed to be using the evaporators in high wind conditions, but they often do. And then this is just a graphic showing the potential for groundwater depletion. This only goes through 2023, but with 2024 numbers, it's over 70 million gallons of water that have come into the mine shaft that have been lost. And that's groundwater in an arid place, where I don't think I need to convince anybody that groundwater is really important. So that's all I have, and I'll pass it back to Len.
All right, I'm actually going to pass it over to Dr. Laura Crossie to tell us a little bit more about the groundwater.
Thank you, Amber. Can you guys hear me? Can you hear me?
Yes.
Okay, okay. So Amber, that was fantastic. I love your chemistry slides with the drops. So I think everybody's, kind of vibrating now, seeing that contamination. Amber took us to, I think you said 30,000 feet, and I'm probably even going to go higher and farther, because the question is, why would the impact statement have been so wrong, or why could it be so wrong? And what is it that makes many of us, especially myself and my contributors, that's Carl and Dave Kramer and others that have worked with both me, Carl, and Dave through the years on different aspects of the problem. So I'm going to just try to give you a big picture idea of the complexity of this beautiful Grand Canyon region. And I'm starting with some pictures of Havasu, which is, out there as one of the potential places, highlighting cultural need and current use, the waters that are used by many people, the springs, the ecosystems within the canyon itself, the national park, what the things are that are at risk. I think, Amber, you also really outlined those beautifully. The picture of the mine again, its proximity to the canyon. This lower picture shows Red Butte that Amber mentioned. Maybe it looks like it's out there and isolated, but in terms of the horizontal distance to the canyon, we'll see that there are some actual studies that show that water can move very, very rapidly in this unusual situation of a deep, deep canyon cut into a gorgeous plateau of what we get lulled into thinking of as these beautiful layer cake kind of a stratigraphy. I put my kind of bottom line right here on this slide, just so that I know I get lost in the weeds, because that's kind of my business, is spending a lot of time in the weeds. And the big picture is that we do actually have connections between these different layered aquifers. We have many lines of evidence on the plateau, in the Grand Canyon region, in the areas in close proximity to the Pinyon Plain Mine. But I do want to emphasize that my work has not been done on the mine or the wells that are right here monitoring this, but in the regional area surrounding this, both on the north and the south rim. Here it is, the beautiful layer cake stratigraphy. And for decades, people focused on the layer right down here at the confluence. This is the confluence between the LCR in the beautiful turquoise blue, that's the Little Colorado River, and the main stem of the Colorado River flowing from left to right. On surface waters, when we see waters coming together, sometimes we get this amazing view of how waters can mix. Above this confluence, we don't really have the influence of these turquoise LCR waters, which are essentially 100% groundwater at this point. When it looks this blue, it's got very little runoff in it, and it's emerging from Blue Spring and other springs a little further up the LCR drainage. So this is essentially groundwater flowing in to the snowmelt and rain runoff from the Colorado Rockies and entering the region. So we can clearly see when surface waters mix. But what's been really difficult is for people to understand the natural mixing that is happening in these incredible Colorado Plateau aquifers, even now, not just with contamination, but the normal course of flow paths of this complex groundwater involves a lot of mixing in the subsurface. And how do we sort of learn that? How do we do that? Well, in terms of studying water, I'm really more of a hydrochemist. I study the solutes and the gases in the water, mostly invisible to our eyes, but very well measured, and they help us understand flow paths. They help us understand how groundwater interacts with the surrounding rock matrix, and they help us understand when we've had mixing occurring. So we use a whole laundry list of what I call natural tracers. So way before the issues with the Pinyon Plain Mine came up, I was looking at understanding the groundwater mixing that applies, across the region, both the north and the south rim. So it was a very general, basic science type of study. And one thing that pops out, and if you've been fortunate enough to be down in the canyon, you've maybe seen some really different looking waters. We have what I kind of refer to as upper world waters. These are the ones in the top row. Vasey's Spring, Roaring Spring, the place where the source of the water on the South Rim is coming from. Here's just some photographs showing you these waters tend to be cooler springs than some of the others. They're very fresh water. And of course, in the case of Roaring Springs, that's the potable water that everybody really wants to drink. The ones at the bottom, to me, are the most interesting. They're not necessarily the best drinking water, and they're harder than the hardest water you would ever have in your tap. These are highly mineralized waters. They deposit the beautiful travertines, the rimstone dams and terraces, Travertine Falls, Pumpkin Spring, a very interesting natural travertine mound spring. So we have these deep waters that have had much longer residence times in the canyon. So we can trace these waters and their pathways by using chemistry. Now, this is sort of a crazy graph, and I'm not going to go into details. But one thing that sort of popped out to us when we did the stable isotopes of the water molecules themselves from all these different springs, hundreds of different springs in the region, is that we saw that the South Rim springs generally were up here. I think maybe, can you see, let's see if you can see. Can you see my pointer? Maybe it's
Yes.
Yeah, okay. So we had one batch of springs up here, and we have another batch of springs down here. And they were really pretty well separated across this graph, which is essentially the water molecule itself. There's nothing, it's an isotopic analysis that we do, but these are stable isotopes, not radioactive isotopes. And we have waters that are heavier and waters that are lighter in terms of their actual mass. And so that just comes about because of the natural distribution of stable isotopes in Earth atmosphere. And it turns out that when we're on the North Rim, these are the springs that are coming more from the North Rim, that we have a higher elevation, more snowmelt contributing to the springs, and it causes them to be shifted in that direction, kind of down to the left. For the heck of it, I put the Colorado River down there in Lake Mead. Well, that is coming from much higher elevations, much colder waters up in the Colorado Rockies, and it's even further than any of the waters in Grand Canyon. So that's, just sort of in a way, it's a map, but it's a chemical map. So we used this idea, and thinking about the North Rim and the South Rim, we thought about the water supply system. So again, thank you, Len, for mentioning, the recent, very recent, even ongoing devastation that's happening right here at the North Rim. And here I am showing a slide as if this is going to all just continue to happen. We don't really know what's going to be happening with this new water system. But here's Roaring Springs. The water is coming from the North Rim, coming down across the river. It gets lifted up to the South Rim. And this has been going on for decades and decades. So we've essentially taken this tagged water isotopically, naturally, in a different isotopic space than the South Rim water, and we've been using it, distributing it along the South Rim, piping it around, leaky pipes, washing dishes, flushing toilets, and so forth. So when we come down here to what's now Havasupai Gardens, this is an older slide, when we come down and look at these springs that are along, for example, the Bright Angel Fault, we find chemically that we get an amazing influence of the North Rim water. In other words, it's a natural experiment that people have been doing for more than 30 years, taking isotopically what I would call light water sitting up in this place. Isotopically the water over here, the Roaring Spring water, and then pouring it and mingling it. And it turns out that the South Rim housing, the campgrounds and so forth have been drawn from what would normally be a South Rim signal. And we can actually, come a little bit quantify the fact that we have released this water up at the rim, and it's finding its way down to the springs in Grand Canyon with that isotopic signal. So now this stuff was published, a long time ago. We did it geochemically, but not isotopically. And so this was definite evidence that we have fast traveled paths coming down. That's these blue arrows. And we have slower paths moving through the Redwall Muav Aquifer, where the water has a longer residence time. And I kind of use this idea of fresh water in the blue bottle and then sort of more Gatorade because that's got more salts. We even have a set of waters that are real fizzy and bubbly. These are the ones that give the blue color and effervesce CO2 and actually precipitate travertine. So we have a complex mingling of different types of water in the canyon region, and that's on both the North Rim and the South Rim. And we use this experiment of taking North Rim water, piping it over, dumping it out on the South Rim, and finding evidence of it way down, near river level. So that's just, very human timeframes. Well, in the recent decades, or probably the last 10 years, the park has done a really amazing, along with some other scientists from NAU and now some folks that have relocated to Kentucky, but they're continuing on, and the USGS has jumped on board to help do these tracer tests. They were looking for the source of Roaring Spring water. So this is a very busy map, but you can kind of orient yourself with the Colorado River flowing around here. We've superimposed white lines showing us the faults. So our previous work highlighted how important these fault and fracture systems are for allowing water to move from the near surface on the Colorado Plateau rapidly vertically downwards toward the Colorado River and toward the low-lying regional world-class karst aquifer that is the Redwall Muav Aquifer. So the water, even though groundwater rates are generally slow, people will quote, millimeters per year, whatever. In karst aquifers, you can have fast flow. And when you have faults and fractures that allow vertical downward transport and a mile deep canyon right here, you have the opportunity for very rapid flow. So what they did was they put in tracers in these round circles up here on the Kaibab upwarp. And then they put receptors, that is, things that look like little tea bags, out in the springs, all the way around this plateau, all the way around like this. And lo and behold, they picked up those tracers from 1 to 2 snowmelt seasons afterward, as far as 20 or 30 kilometers from the surface, dumping it in a sinkhole up on the Kaibab Plateau, trickling down and hitting a spring like Vasey's Spring, eventually Roaring Spring. And so they established these connections that were much further, and they were not in the stratigraphically predicted direction that you would have based on the tilts of the beds. Because regardless of your whole layer cake being seemingly simple, there are vertical cuts through that are the natural faults and fractures highlighted here in white throughout the plateau. As Amber said, there's plenty of places where this can happen and did happen on human timescales. So these are studies now in the decades after that approved impact study, which I think reasonably would give pause to some of the assumptions that were in place in the 1980s. It's not like people were just sitting around on their hands for the 40 years since then. We have learned a lot, and we have so much better chemical and detection methods. So what is this applying to the South Rim? Well, yes, our work here showed that the distribution of water here has come down the Bright Angel Fault and shows up in tracers. Since our work with the stable isotopes, we did one study where we used pharmaceuticals that were distributed through the water treatment plant here on the South Rim. And then they go down the fault and show up in the spring. And since then, the USGS has reproduced those and shown Monument Spring, which is right down below the old abandoned uranium mine over in the western part of Grand Canyon Village, the Orphan Mine. So they've shown connections from the surface down to that level readily. And these fault structures are moving waters laterally. You can see the scale bar up here from 0 to 50 kilometers. They put it here, and a season later, it is moved completely perpendicular to the dip of the beds along fault structures and shows up in springs over here. So that's a real gotcha. and I think warranted a reconsideration, which really hasn't happened. This is just a close-up map view. I think if people have questions, we can come back to this later. You've seen a visual view. This is just sort of a cartoon highlighting the parts that have to do with the hydrology. The big blue circles there represent the, they're numbered 1, 2, and 3 are the monitoring wells that are on the site, that is inside the fence. There's an additional well out here that's monitored, that's outside the boundary, but of course it's in quite close proximity to the boundary. And there's also a deep well. So I'm going to show you this view. This is direct from Energy Fuels themselves. And in the academic world, we call this a Caltech plot. That is, there's something on the vertical axis, that is the vertical elevation or height or depth. And on the horizontal axis is nothing. And we can't really tell where anything is because it isn't really a cross section, even though it's drawn as if it's cross section. So it shows us where the breccia pipe is, where the different mineralization is, the cone of depression from the pumping of the Coconino aquifer that the mine's been doing. Of course, as soon as they stop and heavy pumping there, this thing fills back in. It highlights the breccia pipe itself. Breccia meaning broken up and crushed rocks. These are naturally fractured and ground up rock materials that are extremely concentrated within the rocks right here in the vicinity of the mine. And then below is this RM aquifer, which in the past, is considered to be completely, separated by an aquiclude, which would be a natural blanket layer of fine-grained rock that wouldn't allow any transport between these different layered aquifers. We know that that's not the case, even though, yes, that the rocks are more fine-grained, they aren't continuous, there are faults and fractures that allow vertical transmission. And then secondly, when you think of where, I'm going to go now to a more sort of a cartoony view of that stratigraphy at the Pinyon Plain mine area, just highlighting the more than 17 miles of vertical drilling like this that has gone on both in the exploration phase and the various development phases of the mines. Those are holes which have been in some cases filled, but how do you, all wells leak, we know from the methane leakage that we find all over the Colorado Plateau, that we try to seal up wells, but Mother Earth doesn't really help us in that endeavor and finds ways for this material to fracture and crack. And so there's all kinds of communications that can happen. The high concentrations that Amber talked about are the waters that they're removing from right inside the zone where they're actively mining. They have to keep the water out to do the active workings. Those are a real high in concentration, and that's why they're, pumping it out and then trucking it off. That's a whole question that we could follow up with. But there's one well there, the deep water supply well that goes way down to the RM aquifer. So there's claims like, well, we're monitoring the regional aquifer and we're not seeing anything. Well, it's not like the water is like a lead weight that's going to necessarily just go straight down. It's going to move laterally as it diffuses and migrates. The water direction of flow in the Coconino aquifer is not even known. We nearby have the Grandview Fault, which is a fantastic type of a conduit, exactly like Bright Angel and other faults that have distributed groundwaters throughout. That's why we see the travertines building up along these structures. We know they are the superhighways of groundwater transport. So we could be having movement off-site, not in the area where a monitoring well is right here. And if they're saying, well, we're monitoring off-site, it's like 20 yards off-site. Well, I mean, I shouldn't say 20 yards. It's not exactly 20 yards, but it's not far off-site. Whereas we just showed places where they've poured a tracer into a sinkhole in the Kaibab, and it showed up 50 kilometers away 1 year later. So, and going all the way from the Kaibab down to a spring, which is emitting right from the RM aquifer. That is the concern. That's an understanding that has been happening in the last 20 years, much more widely known, and should have justified a serious reconsideration. So I know that it didn't go into any details about the other constituents. You know, before the uranium shows up, there might be many other things, the salinity, other types of chemicals. It's not only uranium that is the negative aspect of what happens during mining. And the oxidation, the water flushing in to a shaft area, that is going to create a problem. You know, they thought they had the shut-in of the American mine up there, you know, when the Gold King mine spill happened. That was another case of the mine was shut up, the water just continued to react in that thing, and once it broke out, you know, it went everywhere. So that's what shutting it is now. If you backfill, that is gonna help. But this is not an easy. No mining is easy, but this is a particularly complicated type of a place. I know I probably went too long, and I'll give it back. And if people have more questions, I would be more than happy to go over those.
Thank you so much. Yeah, and folks can type questions in the Q&A, and Dr. Crossy, you can respond to some of them in there. And I'm now going to turn it over to our final panelist, Leona. I'm going to pin you. Thank you so much. Go ahead.
Okay, so I'm gonna share my screen. I got a presentation, and then I have also I would like to share another screen after this. So I'm gonna cruise through some of this pretty quickly. A lot of it, I'm happy to be on this panel. Thank you so much for the invitation. And Amber and Laura covered a lot, so I think there's a lot that people can ask questions about. I'm going to focus more on not as much on the transport as I would like, but I'll give some updates, and then talk about nuclear colonialism, and then why there's this push for new nuclear, and then some current events, current threats, and actual community organizing that folks can get involved in. So folks who have seen my presentations might recognize this slide. And the basic gist of it is that nuclear colonialism is really an ongoing process of colonization of our land, our water, our resources. And it's not unlike the settler colonialism that we all lived through as Indigenous people. You know, there was first they tried to kill us off, kill all of us through genocide, and then relocate us, and then basically assimilate us. So these things are still happening today. As the late Cleve Benally referred to it, it's more of a slow genocide when we're dealing with the impacts of uranium mining to our health, and how that results in cancers and various illnesses after some time. You know, it takes a long time for cancer to develop, and it's really hard to pinpoint it back to what source of radiation exposure or that kind of thing. But there's also there's generational impacts. So impacts to our future generations that are really still unknown. And so we're dealing with ongoing health impacts, and then we have the loss of land, the loss of clean drinking water for uranium and for nuclear power plants, and then also nuclear weapons development that causes relocation today. And several other things from our history are still impacting us, such as things that were in the Navajo Nation Treaty of 1868, such as signing away our right-of-ways and basically giving these easements to future energy developments. So that's one of the hindrances of why Navajo Nation does not have jurisdiction on the US and state highways, which makes it really hard to stop uranium transport, resulting in the tribe basically giving in to energy fuels and then entering into this, secret agreement that we're dealing with now. And I can talk about that more if there's time, if people have questions. One of the biggest challenges, like Amber was referring to, the 1872 mining law, and we can see that play out at the Grand Canyon, at Oak Flat with the copper mine, and then, around the Black Hills, and then also in New Mexico on Mount Taylor. So these are all sacred places. And so we're still dealing with that, which was basically a policy designed to allow for the theft of our land through mining. And so this idea of manifest destiny and all of that, we're still dealing with that today, as well as the General Allotment Act. And in the Eastern Agency, the checkerboard region makes it very complicated and even starts to, it's a divide and conquer tactic. And this is exactly what the United States is still doing today, is dividing communities. And now we're dealing with the issue of cleanup of abandoned uranium mines that's resulting in a lot of conflict between communities. And the reason why we're very concerned about uranium, obviously, is for the most obvious reason is the impacts to human health. And so whether we're dealing with uranium exposure from mining or milling, transport, and also other nuclear facilities. We have a lot in New Mexico. So right now I'm in Albuquerque, New Mexico, and a lot of these impacts are not studied. There's some studies that do show, how uranium gets into from different exposures and internal exposures, how it affects our body. And this slide is part of a longer presentation. It's an excellent presentation that was put together by Cindy Folkers, and the graphics and everything, we produced this under the Radiation Monitoring Project. But if anyone wants to read more about that, you can just do an internet search for the uranium map in our bodies, and then it'll go into some of the different how uranium decays, and then the different decay products, how that can cause health problems either from external or internal exposures. And so just going to, some of the legacy issues, the legacy is basically all of the past mining, mostly from the Manhattan Project and Cold War. We're dealing with over 20,000 abandoned uranium mines across the country. So this is a really interesting interactive map where you can zoom in and see, exactly how many are there in those places. But on Navajo Nation specifically, and Hall No, we started out, trying to stop the entire transport, looking at everything from the mine to the mill, which is the mill being on Ute Mountain Ute lands. I'm helping to support the local community to change the narrative around the mill. So they don't like the name White Mesa Mill, because that's the name of their community, is White Mesa. And so we're referring to it as the Energy Fuels Mill. Since the mining has started and since the transport has started, Hall No has been more focused specifically on Navajo Nation and how to address the different problems there from the transport as we're dealing with new uranium mining proposals. So these are the abandoned uranium mines that US EPA has identified on Navajo, which they say 523 distinct sites, but we know there's a lot more when you count exploratory drilling and the mills. So the uranium mills, those are very problematic because they use a lot of water. And this is, the mine is where they take the uranium out of the ground, and the mill is where they process it, crushing and grinding it and using all kinds of solution to separate the uranium. And everywhere there's a blue square where there was a mill in the past, this is where there is underground water contamination. So underground plumes of radioactive contamination. And the only mill that's active today is the Energy Fuels uranium mill in the Four Corners. So that green square in Southeast Utah. So that's one of the biggest concerns for me today. This is one of the places where uranium production kind of bottlenecks. And I think it would be very useful if a lot of people help to support the fight against the mill, because it's not only for uranium ore, they have what's called a license to process alternate feed. So basically any kind of nuclear waste from all over the world, really, they get shipments 24/7. And because of Hall No and some of the work that the support we have from different agencies, and of course the Navajo Nation stepping in, despite that secret agreement, there were some limitations put on transport. So I would hope other communities could also push on their different jurisdictions to also get limitations, like there's a curfew, they do a radiation scan before the truck enters the res, and then as it exits as well. And so there's not a very good emergency plan. I can talk about that later, but yeah, so this is a map that shows where the contaminated places are on Navajo. And I just want to highlight the mills because these are also very problematic. And sometimes people, don't really talk about them as much. And so the next slide specifically is about, some of the issues Hall No has been focused on and what's going on with that. If you have questions, just put them in the chat. One of the things when we started Hall No, we had a base in Flagstaff. And so we had, again, the late Cleve Benally, who made this map, who developed our social media campaign and our website and did a lot of work. And unfortunately, we no longer have anybody in Flagstaff. And our focus is really Navajo Nation right now. When we started the campaign, I, being in New Mexico, was really focused on Roca Honda because Roca Honda is also owned by Energy Fuels. And if the transport ever started, from the Grand Canyon to the mill, it would be soon after. I imagine, this was in 2016 when the map was made. We were also looking at Roca Honda as a place where transport could occur. And so since we have started Hall No, unfortunately, the mine has started, and that's what we're talking about tonight. And then the transport, it started with only 2 trucks per day, but they can go up to 12 trucks per day. They have increased to 4. I know they were planning to increase to 10. So right now, honestly, I'm not exactly sure how many trucks they're transporting, but they can do up to 12 per day. And this is something that folks are really asking where to report issues. There's a lot of concerns with trucks being parked on the side of the road, especially where, like at a food market and, where children are. And then, of course, everyone has probably heard about the sick uranium truck driver. And so there's also a concern for worker safety and worker exposure. And if you're interested in getting involved in that, please email us at stopcanyonmine@gmail.com or contact us on our social media so we can get a working group to start addressing some of the monitoring issues. But yeah, so there's a lot of work. There's a lot of people working to educate each other and the resistance against both the mine and the mill. And we have some pictures here also of folks that are working on RECA. So RECA is, I just ignore the title slide there. I was kind of talking about some of my other work. But really quickly, I'm going to go through the next few slides and just share. I know my time is also up, but the reason why they're pushing for new nuclear right now is as a false solution. They're calling it a solution, but it's really not a solution to climate change because what they're saying, and it's basically a lie, that nuclear energy is low carbon, sometimes no carbon, carbon free. These are all the words they use, carbon neutral. And in some states, they even passed laws to label it as renewable, which it is not. And that's because they only count the carbon footprint at the nuclear power plant. They don't count anything before, which is all fueled by fossil fuels. They don't count the waste management and the most dangerous waste that needs to be contained and isolated from humanity forever. They use a lot of metal and concrete. They don't count, the carbon footprint of forever. So that's why they say it's nuclear, it's carbon free. And then also that the nuclear fuel chain is not just for energy, it's also for weapons. And there's a lot of weapons development stuff happening, especially here in New Mexico. And so basically, looking at this map, wherever there was past mining, there's going to be a push for new mining if there's uranium deposits. And so some of the issues Amber already went over. But right now, what we're dealing with, especially from Trump's executive orders and fast tracking of mines, is new mines and new uranium mills. And 3 of those new mines in New Mexico are on our sacred mountain. And then one project is on the Navajo Nation. So there's a lot of things happening. We're concerned about the shrinking of national monuments. And then one good thing, I think, it's kind of good, is that the RECA expansion was basically passed. And so that's something, it's only for 2 years. This week, we're dealing with a lot of things in New Mexico because there were 2 disasters in New Mexico that both occurred on July 16th, about 5:30 in the morning. So the first was the Trinity test and then the Church Rock spill in different years, of course. So there's a lot of events this year. I know folks in New Mexico are more aware of this, but I just wanted to share it's the 80th anniversary of the bomb. And so there's a candlelit vigil where the Trinity, with the folks who are dealing with the Trinity fallout, they are happy that there's RECA expansions, but it's not enough. And then on Saturday, there's going to be a big event in Church Rock to remember that uranium spill. And then there's other events coming up. We have one in September, there's the walk in October, and then the film festival in November. And that's, yeah, it's a lot of stuff, a lot of organizing, things that are happening. And yeah, we invite you to join us and get involved and help us to fight these monsters.
Awesome. Thank you. So as I think we can hang out and answer a couple questions, I do want to flag as people are we're having some people trickle out. We've mentioned several actions that you can take, and I put these in the chat, but you can contact Arizona Governor Hobbs and ask her to revoke the aquifer protection permit for the Pinyon Plain mine. I think our Grand Canyon Trust, Environment Arizona, Sierra Club, a bunch of other groups have been working to get the governor's attention on this. You can also contact your member of Congress and ask them to contact the Forest Service. And we're asking the Forest Service to conduct a new environmental impact statement for the Pinyon Plain mine. It's a little less likely that the Forest Service will be responsive, but we think they're more likely to be responsive to members of Congress. So asking your member of Congress to contact the Forest Service. And then if you're feeling extra motivated, encourage you to write a letter to the editor calling for the Pinyon Plain mine to be closed. Letters to the editor are incredibly helpful, especially if they're from all across the country. So those are some action items. We've got a couple cues in the Q&A. So let's see if I think Dr. Crossy, this one's probably for you. Can you talk about groundwater in the Colorado Plateau flowing to the river and how it's monitored for elements like uranium, and if the budget reductions at USGS and EPA are likely to impact those efforts?
Let's add NPS.
And
because-
NPS.
Because
And
the NPS has a natural resource division who has become, kind of integral to some routine monitoring, and they work hand in hand with folks within the USGS. So I have no question that not just the budget cuts, but literally right now with the travel budgets, which have hit agencies in really strange ways that are unconnected, it is as if that people don't really know what those people do. But the USGS had a $1 a day travel budget. Well, the people are actually here in New Mexico who are doing the monitoring at the Canyon mine, or Pinyon Plain mine. And, for $1, they can't drive over and sample. Now, as an academic scientist, I'm spoiled. If I want to go and drive somewhere, well, I get in my car and I drive there and I do what I feel I should do as long as I have the permits, right? I'm not limited in the same way as a federal employee is limited. I can answer email. They are really, really handicapped, and it's not just the money. There's going to be fewer staff. So what normally happens in Grand Canyon is there are a variety of different people who work there for different purposes. There's ecologists, all kinds of folks that periodically sample. Let's focus on the waters that are being sampled and analyzed as required for the monitoring. One of the complications there is what they're required to analyze. Somebody said, well, of course they need to monitor the uranium, the arsenic, and they list, 4 or 5 or 10 or 12 or 16 things that they need to do. Well, to understand what's happening in real waters, and I've got this really strange water behind me, you don't just need to know about the bad things in the water. You need to know about every chemical in the water, even simple things like the sodium and the chloride, because that has a huge influence in how those waters behave, even their toxicity. Leona, you showed a beautiful slide of a woman and different biological pathways through which, whether it's uranium or whether it's lead or arsenic, sulfate. I saw there's another question that's kind of related, which had to do with what about the waters that are now marked as, not good to drink. Some of that in the springs along the trails is because of, grazing and so forth that happens up on the rim. The biological material gets in there, and so you can get, sick from that. It's not necessarily heavy metal poisoning. For a long time in the US, people would take the waters. They thought drinking heavily mineralized water, getting lithium, getting, these special substances, this still happens today. Drinking a little bit is not the same thing as rearing your children and for the whole human cycle, drinking that water, which is what happens at Havasupai, where people are drinking and using, the water that they have available to them for their whole life cycle. It's a little different than, debating if you're so thirsty you need to take a sip. It's probably not going to kill you, but the buildup and the use of things is really the problem.
Thank you so much, Dr. Crossy. I think it looks like we've been very efficient about answering most of the questions. So I think we have one more and then we'll wrap things up here. So it is, what is the number one thing you wish the public understood about the Pinyon Plain Mine or the nuclear industry in the Southwest? Leona, do you want to take a crack at that, and then others can answer if they'd like to?
Can I go next? Sorry, I'm answering one of the questions.
Oh, yes. All right, go ahead, Amber.
I'm happy to answer this one. I mean, the number one thing I wish people knew is that the mining company is basically taking advantage of a convenient narrative, a convenient public narrative right now, to try to amplify their relevance in this moment. But the reality is they don't have the ability to, Pinyon Plain Mine does not have the ability to meaningfully contribute to the nuclear fuel cycle or energy security or any of those things that they're kind of hooking their train onto. Which I talked about the reality of uranium deposits across the country as a whole, and Pinyon Plain Mine is a teeny tiny itsy bitsy fraction of the national deposits, which are still relatively insignificant. So that's what I would say.
All right. Anyone else want to answer? What's the number one thing you wish people knew?
Well, for me, I think the number one thing is to know what is the local nuclear fight in your community or in your state. And so if we can stop all the nuclear power plants and stop nuclear weapons, we shouldn't have any need for uranium mining. And so it's not just the uranium mines, there's uranium and nuclear facilities all over the world. And so folks always ask, how can we support? And I tell them, well, find what is your local fight, find the people fighting it, get organized, do something about it. And if there's no organization or no group, then form a group, start organizing, educate yourself, talk to elected officials, tell your friends and relatives. But I like to focus on youth, and I like to focus on educating young people, because we're all going to be gone. The older folks that are fighting nuclear from, the 80s, that wealth of information needs to be passed on. And so we need to educate our young people and get them involved, because they're the ones that are going to inherit all of this. And so I hope folks can help to tell young people what's going on, have presentations in schools and, things like that, and then come to our events.
That was a great answer. And I think with that, we'll wrap things up. Everyone had so much to say, and we had so many great questions, and really appreciate everyone that stuck with us. We'll send an email out with a link to a recording, as well as links from the panelists where you can read more in-depth information about everything that was covered here. So thank you, everybody, so much, and have a great rest of your evenings.
Thanks, Lynn, for putting it together.
Yeah, thank you.
Thank you
Goodbye.
all.